From the mass of a reactant, you can calculate the numbers of moles or grams of the products. And for this, you need to use mole-to-mole factors, and you can use these as conversion factors. Where do we obtain these mole-to-mole factors? We obtain them from the balance equations. So we're going to do these two problems together. This compound burns with oxygen and in the following balance equation. We want to know if we burn these many grams of acetylene, how much CO2 is produced. So we're going to use our balance equation, and we start with 54.5 grams of C2H2. The conversion factors that we're going to do is always from grams to moles, then moles to moles, and then we can go from moles to grams. So the first thing is convert these grams to moles. We're going to put grams here and then mole here. 1 mole of C2H2 equals to 26 grams. So now we cancel the grams. Now we're going to go from moles of this to moles of this, and we're going to use these numbers in the balance equation. We see that 2 mole of C2H2 equals to 4 mole of carbon dioxide. In that way, this cancels with this. We go to the next step that says from moles to grams, 1 mole of CO2 equals to 44 grams. In that way, they cancel out. Then we do the math, and we're gonna do 54 times 0.5 times 4 times 44 divided by 26 times 2, and the answer is 184.8 grams of CO2. We're going to do this other problem. We're going to determine the mass of NH3 that can be formed when we react 62.3 grams of nitrogen. We're going to do the same using our balance equation. So we have 62.3 grams of nitrogen. We're going to convert that to moles. 1 mole of nitrogen, because we have a 2 here, it will be 14 times 2, that's 28 grams. So grams with grams will cancel out. Next thing we do, we are going to go from moles of nitrogen to moles of NH3. We see for the balance equation, 1 mole of nitrogen produces 2 mole of NH3. And then the next part will be going from mole of NH3 to grams, which is 17 grams. 1 mole, 17 grams. We do the math, and we obtain 675.65 grams. Let's go to the next problem. We have 75 grams of CO2, and we want to know how much of this were burned. So we're going to do the same setup using 75 grams of CO2. We're going to convert that to moles. 1 mole, 44 grams. Then we're going to go from mole of CO2 to mole of this. We say 1 mole of CO2, because these are moles of CO2, right? CO2 equals to 2 mole of C2H2. They cancel out. And the last step, 1 mole of C2H2 equals to 26 grams. And then we do the math. And when we do it, we find out that the answer is C. The next part that we're going to learn is called theoretical yield, actual yield, and percent yield. The theoretical yield is the maximum amount of product that we can calculate, and that our calculations tell us that we're going to have proceeding with this reaction. The actual yield is the amount of products when the reaction takes place. Sometimes we lose products in the process, and then the actual yield is just how much we ended up with. Percent yield is going to be the ratio. Actual yield divided by theoretical yield times 100. We are going to solve these problems. First, we're going to state the needed quantities, write a plan, write the molar masses, and then solve for percent yield. So this type of problem requires a lot of work, a little thinking, so we're going to work it together. We have this reaction over here, and we want to know the percent yield when 50 grams of lithium hydroxide gives 72.8 grams of product. We're going to start recognizing what is it that we have in this problem. First part, this is what we start our problem with, 50 grams of lithium hydroxide. This value over here is going to be our actual yield. So we're going to go and figure out how many grams of this we will get starting with 50 grams of lithium hydroxide. We have done this before, so what we do, convert these grams to mole. 1 mole of lithium hydroxide equals to 23.9 grams. Then we go from lithium hydroxide to the product, and we see that the amount of moles is the same. 1 of these equals to 1 of that. So 1 mole of product equal 1 mole of lithium hydroxide. And then we find the molar mass of this, and 1 mole of this compound equals to 67.9 grams. The theoretical yield is 142 grams. The actual yield was 72.8. So what we do now is calculate the percent yield. It's going to be 72.8 divided by 140 times 100, and the percent yield is equal to 51.2%. What is the limiting reactant? The limiting reactant is the substance that is completely consumed in the reaction. The rest of the products in the rest of the compounds in the limiting reaction are known as excess. So let's do this problem together. We have methanol is our product, and we want to know how much methanol can be formed when we react 3 moles of carbon monoxide and 5 moles of hydrogen. When we're doing these type of problems of limiting reactant, the two reactants are given. So we see that we get 3 moles of CO and 5 moles of hydrogen. So with this, what we're going to do is calculate how much methanol we could get from each. We see if we have 3 moles of CO, we can convert this, and we say 1 mole of CO give you 1 mole of methanol of product, right? So we see 3 mole. And we do the same for hydrogen. They are giving us 5 mole. 5 mole of hydrogen. So we see 1 mole of product, 2 moles of hydrogen. So 5 divided by 2 is 2.5. So what we do is we look at the two amounts, and we notice that this one is small. The smallest amount is going to be the product, and the limiting reactant is going to be hydrogen. It got completely consumed in the reaction, and the CO was excess. There is also an energy change involved in a chemical reaction. We can have reactions that are exothermic. Reactions that are exothermic release heat, and heat is considered a product. So we see some kind of energy as a product. The endothermic reactions are those that absorb heat, and heat is a reactant. So the reactions can be endothermic, they absorb heat, exothermic, heat is released. So let's identify each one of the following reactions. So we could have, that we look at this, heat is a product, so this one is exo. We look at this, heat is a reactant, so this one is endo. Look at this, heat is a product, this one is exo.